Hello, everyone. This is the ICT community meeting. Today's June 13th, Pacific time. So today we have two items on the agenda. First, thanks to Wenja, 3.4.33 is released this morning. Yay!
Yay! And I want to thanks all the people who volunteered to shadow the process. Suyuan, Ivan, Mustafa, and Vivek, thank you very much. Like having shadower really helps to help us to improve the playbooks and pointing out the places that we're missing. And of course, thanks to Benjamin who walked us all the way through the entire release process. Thank you. The more people who participate, the more gaps we can find in the release process, and the better we can make the release process.
Cool. So the second item is Chao about SED performance testing. Chao. Chao, are you there?
Chao, if you are talking, you're muted. I think he is there. I can see his name.
Yeah, some difficulty using the meeting.
Sorry. Okay. Yeah. The unmute button is on the bottom left. Okay. All right. We can.
Yeah, I think people can just take a look at the doc and provide some feedbacks. Cool. Anything else we want to talk about? Cool. Calling once. Calling twice. Calling 3. Yes, we can just have a.
I think Chao just joined back. Maybe if he still wants to talk about the issue.
Oh, okay, cool. Chao, can you want to take over?
Not able to speak.
Oh, he's not able to speak. Sorry. Yeah, I didn't realize that.
Okay, it's okay. Next time.
Okay.
Well, somebody can relate it on chat, I guess.
No worries. It's okay. The link to the doc is there in the meeting notes. And everyone, please take a look. And thanks, Chao, for taking the lead on this.
I mean, if there is no other topic, I can talk about the etcd recent discovery. So people are more aware. If you're not following all the GitHub notifications, there is a pretty interesting case we found during the last robustness test meeting, and I totally lost it. High level, we have already confirmed, or Benjamin has already confirmed, that we have an issue with watch. There's been a long-standing issue, or at least we haven't found, or it's at least predates 3.4, that there is an unfortunate situation where a watch can be missing, or etcd can drop a event on watch in some specific circumstances. And And I cannot find the issue, of course.
Here.
Sorry. Focus
I
on.
pasted in the meeting notes.
Oh, you already added it to meeting notes. So can you just quickly show it? And then yeah. So yeah, another, let's say, not, I mean, a success by robustness testing framework, maybe not great. Still not great. Would prefer to show that there are no other bugs in etcd, but this is not always possible. But to confirm, there is at the end there will be a summary by Benjamin on the issue. It's pretty like 2/3 or even further into. That talks high level. The situation is every time that there is a compaction on a delete revision, which mean which I mean there was a delete event that generated a delete event that were persisted, or delete operation that was persisted, and the revision matching it. If there is a compaction of this revision that the delete happened, etcd will miss this event. Or it will not propagate this event to watchers. Usually in Kubernetes, it's not a problem because Kubernetes only compacts once every 5 minutes. So 5 minutes is a lot of time. Usually watchers are much faster. And in Kubernetes case, watch cache usually, or with recent changes in Kubernetes, at least newer version, only watch open to etcd is opened by watch cache, which semi-guarantees that there is no like pathological cases where watch is very slow or the client is very slow. It doesn't eliminate it fully, but usually watch cache should be pretty up to date to the etcd state. But of course, there are some cases that it can happen. So at least there are some situations that might cause etcd or Kubernetes watch cache to slow down or not be able to ingest all the events, and in that cases it can get behind, and maybe the watch, and we haven't confirmed it still in like Kubernetes cases, but it might happen that the watch will get so behind that it will hit the window and maybe of the compaction and possibly not miss an event and not propagate it. And as this is a watch cache, it's a cache, which means if it's propagated to Kubernetes cache in API server and the API server cache misses an event, it will persist it. I mean, it will store it and will continuously report that, or not be able to report that, for example, some pod was deleted. And until it's reinitialized, like for example, by restarting the API server, it will propagate it. So it will go to all the informers. Like missing an event is can be pretty impactful in Kubernetes. So yeah, we found it. We are fixing it. Benjamin already wrote a document that describes how we expect the compaction would work and how we want the compaction to work, and based on that, he prepared some at least one PR. I think he does some changes to fix the issue.
Yeah, one question. You know, Kubernetes compact etcd every 5 minutes. So how Kubernetes compact etcd? So what's the relation? What's the parameter Kubernetes used to compact etcd? Is the latest revision or the history revision?
It's just sleep. It just reads a revision, sleeps for 5 minutes, and then compacts this revision in a loop.
Sorry, probably I didn't say it clearly. For example, I understand Kubernetes compact etcd every 5 minutes. So each time when Kubernetes compact etcd, so what the revision is, how old the revision is when used by Kubernetes to compact etcd. Is the latest revision or the an old revision?
It's a revision from 5 minutes ago.
Oh yeah, that's totally not a problem for. So I don't think Kubernetes can reproduce this issue. Yeah.
I've seen at least one cluster that was 2 hours. Watch was 2 hours behind
Wow.
in Kubernetes. I cannot say. I mean, I just can say I've seen cases like this. It's not like watch is eventually consistent stream, which and one of the main issues with watch in Kubernetes is the current level of observability is really lacking. So if there is, even if you run the cluster now, like in production, and you can assume the watch works correctly, but there is no easy way to even write an alert based on metrics available in Kubernetes that can say if the watch is up to date. You can assume that because the latency usually is pretty low. Like we assume it's around below 100 milliseconds. But there is nothing that double checks this. Like there is no
Okay.
metric that you can do that. You can, like, when we do it, we usually, or when I do it and confirm, or how we confirm that there is a API server, at least an informer delayed by 2 hours, was by reading the API server logs and seeing that informer is asking about data from 2 hours ago, or about revision from 2 hours ago.
Okay, got it. Okay, so this is not regression is our issue, so we are no rush to fix it. We should make sure it's we understood before we deliver the PR final fix. So the key part, the reason why the issue is so complicated because the compact is related to the watch. This compact may affect the watch. This is one relationship. This is one thing to make the issue complicated. The other thing is the compact is also related to the hash value. We will compute the hash value of the key space to make sure all the nodes have the same hash value to double check. We depend on the hash value to check whether or not there's any data inconsistency. So this is the reason the compact is related to watch, related to the hash value. So there's a lot of connection between each component. So this is the reason why this is so complicated. All the code are just tightly coupled. It's not well decoupled. So this is the reason why the etcd source code is hard to understand. So we need to make sure that we add more tests to cover all the corner case, not only the robustness test. Yeah, anyway, I will work with the FUA to evaluate the impact on the hash value check. Right now, we don't need to change anything on the watch. We can keep the watch as it is. We just need to fix the compaction logic and make sure the change doesn't impact the hash value calculation. Yeah, that's the key point right now.
Yeah, I agree. +1 to that.
Yeah, if anyone had any thoughts on this issue, please feel free to reach out in Slack. I'm open to discuss.
Cool. I think that's all we have for today. Can have 15 minutes back.
I think Xiao's audio is back.
Oh.
Yeah, I got my Zoom working. I upgraded to the latest version. I think I have another issue. I've forgot to paste it here. That's the slow watch impacts put latency. Well, sorry, I need to find that issue. Here, and I can paste to the doc. I have some ideas to improve the latency, but didn't get a chance to working on the code change. Intent left.
Do you want me to open one of those? Oh, I added yours above Merrick's item.
Oh, thanks. Appreciate.
No worries. Do you want me to share one of these?
Yeah, I can.
Or you can
It's
share.
hard
Yeah,
to
go ahead.
share. Otherwise, you cannot start screen share. Okay, are you able to see my screen?
Yep.
Oh, brilliant.
Yeah, we can see it.
Okay. Yeah, so I'm adding some trace log, including adding.
Just let you know yeah, okay, all right. Just make sure you're not showing anything you should be sharing.
Oh yeah, I just hide everything else. I think there's no sensitive data. So I'm running some scale test, and the background is the Kubernetes 5K node scale test. But the architecture is a little bit different than the standard setup. The events resource is not sharded to another etcd cluster. So you will see a huge amount of events mutations in the cluster with the main resource types. So I'm adding some trace logs, including in the Raft layer to show exactly which step is slow. So it turns out end transaction takes the most of the time. So during the end transaction, you're trying to notify the synced watcher, on this specific, this is like the node heartbeat, but it turns out it's after locking the watchable store mutex is taking the most of the time. And the reason is during the sync watcher process, it takes this lock and retrieve all of the revisions from the slowest watcher's revision, next revision till the current revision of the MVCC store, and trying to get all of the key values and decode into some key value objects, and basically synchronize all of the events for those slow watchers. And that process is taking longer than, I believe, the sometimes it could delayed by more than 1 second and breaches the SLO. But it's not a standard setup in Kubernetes, because we know we typically shard the events out. Yeah, so that's some investigation I've done. So my idea of improving this process is it does not necessarily taking that long. Like the sync watcher, the reason to lock this mutex is just trying to protect the sync watchers and unsync watchers, some victims, some data structure there, and but it doesn't have to take that long. I don't want to go into details, but that's just something I think it's worth to share.
I feel like
Because we could have the same problems for other resource, like secrets jobs, like pods, if we have such number of write requests. If the QPS throughput is high enough, we will face the same problem. Just some
That's not true. I mean, Kubernetes has watch cache, and usually there is only one watch to etcd.
Mhm.
But for events, there is watch cache is disabled. So what you're seeing is the results of watches being like costly watch or multiple watches propagating an issue to other resources, and this is only because you run single etcd, and this is not recommended by Kubernetes.
But this can be reproducible for other scenarios, not like
Yeah,
Kubernetes, right?
I have a reproducible command shared in this, and I'm using the pod prefix. So I think in a scale test, I know the watch cache is disabled for events, but the cluster loader has own killer events watcher on events, and the cluster loader will watch the events to know the scheduler basically when the pod is created till the pod is startup, latency, benchmark that latency. Today, upstream is using list all of the events, and in our fork we changed to watch the events to basically monitor the latency of pod startup. Basically, there are two watches for events with the watch cache on events disabled. But like I have to reproduce on the pods. Yeah, there is also some improvements we can make for the benchmark tool, but I didn't have time to finish this. For example, this for loop and using the limiter. It has a upper bound for the write QPS. Because it depends
That's
on.
intended.
I'm sorry?
We need to have a bound on QPS because we cannot assume infinite QPS, because you could always starve of CPU. Like the benchmark are not written ideally, but they're written because they're written in a way that we can benchmark it. It's intentional.
Yeah, I think mostly the issue is like informational. It is informal. Like just for your information, like if you want to scale etcd to the next level, we might need make some optimization, but like it may not be the priority at the moment. Yeah.
Sorry, I see. Get a quick look on the PR. Could you have a simple summary of the PR? So what's the goal? What's the motivation? What's the main change you have did on the PR? Yeah, there's not much description on the PR, just the source code change on the test results.
Yeah. I should add some description.
Yeah, please, yeah.
Yeah, that's on me.
So question, so reiterate in terms of etcd terms, so heavy put traffic can cause the slowness because of the sync watcher process trying to acquire the lock. So there's some
But that's also intentional. Like watch is blocking for write, and that was written, like we cannot change this. Like you need to do it. We first notify the watchers before we update the bbolt, and that's intentional. If we would want to change it, it's a huge change. We cannot.
No, I'm just trying to understand was in terms of etcd terms was the problem. Yeah.
I mean, there's one thing that was previously investigated is that slow watchers are not synced, or the how it's called, unsynced watchers. The syncing of unsynced watchers, which is a mouthful, is written very unoptimally, and there is a separate issue that discusses it and discusses different trade-offs that we could do in fixing it, and there is ready POC even for it. So I'm a little bit surprised that we are diving into this direction when there was already a lot of discussion about this, and it was linked immediately on the issue. So like that's, yes, we have this issue, we have ideas to fix it, and it's already a POC to do that. We don't need to have two separate discussions.
Mark, did you mention, so did you intend to refer the watch cost auto memory issue? Like,
you mean, I mean that in the first comment there is there is a link to what starvation causing out of memory. That's the one.
okay, yeah.
That's this is an in-depth like analysis of what is happening, why it's happening, how we can fix it, what are trade-offs, how object size, how PrevKV impacts it. Yeah.
Yeah, I guess, well, our standpoint of investigating the issue is different, because from what I can tell, okay, yeah, I guess there are trade-off, like either the watch event latency is lower or put latency is lower. We just need to find
It's not up. Can you scroll lower?
Okay.
There is this table that shows the, this, and even lower, how, like,
Okay.
this is one solution, and lower is, I think I would need to double check. Yeah, just, we can just do this. Yeah, we can just discuss it there.
Okay, yeah, I can put new comments here, like just to merge the conversation. Yeah.
Probably we can create a Google Doc to summarize this to have more discussion on Google Doc.
Sure.
Okay. Time is up. Is there any new topics? I'll update the doc.
Have we lost Wenja and Xuan? Maybe they were kicked out.
No, we're here.
Okay.
All right. Thank you.
Thank you, everyone.
Yeah, thanks. Bye.